I've been 3D printing for years, but almost everything I've ever made has been printed on machines like these. These are FDM printers. They melt plastic filament and build a part one layer at a time. I use them constantly, both for projects and for making functional parts, but there is another side of 3D printing that I've always been curious about, and until now I've never really explored properly. That thing is called resin printing. So when HeyGears reached out and offered to send me their Reflex RS Turbo system, I was genuinely interested to find out what resin printers could actually offer someone like me. HeyGears did supply the equipment you're going to see in this video, but I haven't taken any kind of payment for making it, and what you're hearing is my own experience and opinion. And this isn't really going to be a conventional review. There are already so many detailed reviews of this machine out there. Fohammer, for example, has covered it in far greater detail than I intend to. What I want to know is much simpler. If I already have a good FDM 3D printer, what can resin printing add to my workflow? I've picked two real functional parts to find out the answer to that question. Before attempting either of those projects though, I spent some time simply learning the machine and getting familiar with the workflow. I started with a few existing models so that I wasn't trying to learn CAD, resin printing, and a completely new workflow all at the same time. And the first thing that really stood out was the surface finish and the amount of detail. Even on these early test prints, the layers are incredibly difficult to see, and some of the small details are mind-blowingly impressive. But printing models isn't really why I wanted this machine. I wanted to know whether I could use that same process for the kind of functional parts I already designed. If you're coming from FDM printing like me, there is one important difference to understand. When an FDM print finishes, in many cases, you simply take it off the bed and you use it. Resin has a couple more stages. First, we print the part, then the uncured resin needs to be washed from it. After that, the part goes through a final curing process. HeyGears has built the RS Turbo around the complete workflow, so I've got the printer, the wash station, and the curing station sitting next to each other, and all three are integrated into one complete system. That integration is probably one of the things I've appreciated most as somebody completely new to resin printing, because I haven't had to learn a huge list of exposure settings, support settings, washing times, and curing times before I could even get started. The software that it uses is called Blueprint Studio. You import your model, you select the resin you're using, and it can automate a lot of the preparation. Now, if you're an experienced resin printer, I'm sure there are situations where you'd want to take more manual control, and you can absolutely do that if you would like to. I'm a beginner, so for these first projects, I deliberately wanted to see how far I could get by trusting the automated workflow. With the one-click preparation, the software can orientate the part, generate the supports, position it on the build platform, and prepare it for printing. Once it's sliced, I can send the job straight to the printer over the network. The clever part is that the workflow doesn't stop there. The system knows which resin I've used, so the wash and cure stages can use the appropriate automated profiles as well, and they will change based on the configuration of my print. For my first proper test, I wanted to use something I know extremely well. This is a thickness gauge I designed for the Festool Domino. It lets me quickly set the height of the machine for different material thicknesses. I've been making these successfully with FDM printing for a long time, but they're actually quite demanding parts to manufacture, and to get the level of detail I want, I normally switch down to a 0.2mm nozzle, which dramatically increases the print time. The orientation is important. There is some cleanup involved, and because it's FDM, you've obviously still got visible layer lines. So this gives us a really useful test. Can I take exactly the same CAD model, print it in resin, and improve the detail and surface finish without sacrificing the dimensional accuracy that actually makes the part work? And because I designed the original CAD, I've got the actual dimensions here, so we're not going to judge this purely by whether it looks nice. We can can actually measure it. For this print, I'm using HeyGears PAH10 Black. It's one of their engineering materials and was the material HeyGears recommended for the functional parts I'm making in this project. So rather than testing lots of different resins just for the sake of it, I'm going to concentrate on whether this particular material actually suits the application. I've imported the same model into Blueprint Studio, selected PAH10 Black, and I'm going to let the software prepare it automatically. This is the part of the process that initially looked intimidating to me with resin printing, orientating supports, all the different resin specific settings are things I simply haven't had experience with. But here the software has handled the preparation for me. I can check what it's done, slice the model and send it to the RS Turbo. Once the print has finished, this is where the resin workflow differs quite significantly from FDM. The part still has uncured resin on the surface, so first it needs to be washed. Because the system already knows the material I've used, I don't have to guess how long to wash it for. I can use the prepared workflow and let the wash station handle that stage. After washing, the final stage is curing. Again, the system provides the appropriate process for the resin, and once that's complete, we've got our finished part. And this is where things get interesting. Visually, the resin version is on a completely different level. The surface is extremely smooth, the numbers are really clean, and the whole thing looks molded rather than 3D printed. That's not me saying the FDM version doesn't work, it absolutely does, and I've been using that manufacturing method successfully for a long time, but purely in terms of surface finish and fine detail, the difference here is very obvious. The more important question for me though is accuracy. Looking good is one thing, but this is a functional gauge, so if these dimensions aren't right, it doesn't really matter how good the surface finish is. So I took a couple of measurements and compared both versions against my original CAD model. Starting with the overall height, the resin version was just 0.03 millimeters larger than the CAD model, whereby the FDM version was 0.1 millimeters larger, so the resin printer was noticeably closer to the dimension I actually designed. I then measured one of the 7mm stepped sections. The resin version measured 6.99 millimeters, so that's just 0.01 millimeter away from the CAD model. The same feature on my FDM version measured 7.1 millimeters, and honestly I'm really impressed with that. The resin version feels incredibly solid and rigid, the surface is much smoother, and the numbers are exceptionally clean. When you put the two side by side, you can see some ghosting and visible layer lanes around the numbers on the FDM version, whereas the resin version is considerably sharper. So for this particular part, resin hasn't just given me a better surface finish, it's actually produced a part that's closer to my original CAD dimensions as well. There is another side to this though, because resin printing isn't simply FDM printing with a better surface finish. You're dealing with liquid resin, so gloves and sensible handling are part of the process. You also need to think about ventilation, and you've got the additional washing and curing stages afterwards, so changing material is more involved than it is with FDM. If I want a different color on one of my bamboo printers, I can load a different filament and carry on. With resin, if I've already got material sitting in the vat and I want to change something completely different, I need to deal with that resin and clean the vat properly first. That's not necessarily a problem, but it is something I hadn't really appreciated until I started using one. For something like this thickness gauge, color matters to me as well. I normally make the FDM version in green, whereas the PAH10 material is black. There are obviously different resin materials and colors available, and parts can be finished afterwards, but if I wanted to manufacture something like this regularly, material choice and color would be part of that decision. HeyGears also sent me an additional heated resin tray for colder environments, and living in the UK, that is normally applicable. However, I haven't needed to use it here because the workshop has been warm whilst I've been testing. So everything you've seen here has been done with the standard setup. So the thickness gauge we just made tested detail and accuracy. However, for the second project, I wanted something much more obviously functional. Behind my laser setup, I've got a pegboard, and I designed a custom bracket that lets me mount my AC Infinity inline extraction fan vertically onto it. The original bracket was printed in PLA on an FDM printer. It worked, but after being installed and adjusted, 2 of the 4 mounting points have already snapped. Now, I want to be really clear here. This doesn't mean FDM can't make this part. I could redesign it, change the print orientation, or use a more specialized FDM material and almost certainly improve it. That's not the point of this comparison. What I want to know is whether resin, and specifically the PAH10 engineering material, gives me another useful option for a part like this without me having to redesign the original CAD. So I'm going going to take the same design, print it in PAH10 black, and see whether it survives the actual job I designed it to do. You've already seen the full workflow, so I'm not going to go through every step again. Same process, import the model, let Blueprint prepare it naturally, print it, wash it, and finally cure it, and this is the finished bracket. And once I'd assembled everything, the first thing I noticed was just how much more rigid this version felt compared to the original PLA bracket. Everything fitted together really well, and visually it is very clean, but the real test was actually putting it back onto the pegboard and mounting the AC Infinity fan, and it fitted perfectly. The mounting points engaged really nicely with the pegboard. It's a very snug fit, and most importantly, all 4 of those mounting points survived installation without any problems. Compared with the original PLA version, this feels considerably more solid and much less flexible, which gives me a lot more confidence in it for this particular application. Obviously, I can't tell you how it will perform over months or years of use yet, but I'm confident enough in the results that I'm leaving it installed and using it to support the fan in my workshop. And I think that's actually a really good example of where resin printing could fit into my workflow. I'm not saying I couldn't have solved this with FDM, because I'm sure I could have changed the material, orientation, or design, but I've taken exactly the same CAD model, manufactured it using a different process and material, and ended up with a part that for this application I much prefer. So after actually living with this system and using it for real projects, has resin printing changed how I look at 3D printing? Yes, it has, definitely, but probably not in the way I was expecting. I'm not getting rid of my FDM printers, not even close. For large prints, quick prototypes, multicolor prints, and a lot of the everyday things I make, FDM is still incredibly convenient. I can load a spool, hit print, and in many cases take the finished part straight off the bed. Resin is more involved. There's liquid material to handle, there's washing and curing, and changing materials takes more effort. But what I've discovered is that it gives me another manufacturing tool with a completely different set of strengths. When I need extremely fine detail, a really clean surface finish, small accurate components, or access to engineering resin materials for a particular application, I can now make parts that I would previously have approached very, very differently. And for me, the biggest surprise with the RS Turbo hasn't really been the print quality. I expected resin to look good. It's been how approachable HeyGears has made the complete workflow. As somebody coming into this with virtually no resin printing experience, I've been able to import my own CAD, let the software handle most of the setup, send it to the printer, and then move through the wash and cure stages without having to become an expert in resin settings first. That doesn't mean there isn't more for me to learn, there absolutely is, but it means I could start making useful prints almost immediately, which is ultimately what I wanted to find out. So for me, this isn't really FDM versus resin, and I don't think one replaces the other. What this has done is add another process I can use when the project actually benefits from it. I'll put the relevant information for the HeyGears RS Turbo and the materials I've used in the description below, so if you would like to take a closer look, feel free to do that. And if there are any other functional parts you would like to see me try with resin printers, let me know in the comments, because I've definitely got a lot more experimenting to do with this machine. And my biggest takeaway from this video is just how strong and functional the prints have been from this resin printer. I was so intimidated for a long time because it looked like a lot to learn, but take it from me when I give you my honest experience, it really is beginner friendly, especially with this setup in front of me. And if you're looking for that other string to your bow, then I think this could be the answer for you. So thank you so much for watching. I hope the video has been useful to you. As I said, there are links below if you're looking to get one. And if you have any questions, put them down below. Have a great day, and I'll see you all again soon.